The next topic is health data example. Here we are calculating users' age in days. And let us discuss a small topic about incremental development. Incremental development is a process of writing, compiling, and testing a small amount of code. And after doing this, again we will perform writing, compiling, and testing on another small amount of code, and so on and so further. So, like, if we practice doing this, if there is a small error in a small piece of code, it is easy for us to rectify rather than debugging the entire large amount of code at one stretch. And coming to example over here, like health data, as we said, we are calculating the user's age and date. So we have used the scanner class, and we have declared into user age in years, user age in days. So now we have to system out dot print prints the enter your age in years. User age is equal to scanner dot next int. We are using the scanner to read the input from the keyboard. User age is equal to user age years into 365. So coming to last statement is to output, like you are dash user age days and dash days old. And so coming to next topic is floating point numbers or double, like a floating point number is a real number containing a decimal point that can appear anywhere in the number. For example, you can see here 98.6, 0.00001, or minus 55.667. So this is a floating number. Generally integer will be 98 and floating will be like 98 point some xyz. And a double variable stores a floating point number. So double is will have more places after the decimal point. And you can see this is how we declare a double variable, double miles travel. So a floating point literal is a number with a fractional part, even if the fraction is 0, as in 1.0. So 0 is a floating point literal. Scanner's next double method reads a floating point value from the input. So for example, current temperature is equal to scanner dot next of double. If the dividend and the divisor in the floating point division are both 0, then the division results in a not a number, that is NaN. You can see here example over here. The default output of pi is double, which is 3.141, so on. And yeah, if you see over here, if you reduce it with giving something like zero point 0.4 a float, only the 4 floating literals will appear after the decimal point. You can see in the next line of the output. Coming to the scientific notation for floating point literals, scientific notation is useful for representing floating point numbers that are much greater than or much less than 0, such as 6.02 into 10 power 23. So this can be represented in scientific notation as 6.02 E23, which is nothing but E preceding the power of 10 exponent. Similarly, coming to the constant variables, as we know, variables value changes whenever we want to change the value or when we assign the value to a variable. If you want to declare a variable to be constant, and if you want to identify that, uh, if we want to, like, if we don't want to change that value, we then declare that variable as a constant variable. So constant variable is also known as a final variable. We like, if you want to identify that, we just use the uppercase letters for a constant variable, as in the case of final double speed of sound or final double seconds per hour. Coming to using math methods, so a standard math class has about 30 math operations known as methods. The math class is part of Java's standard language package, so we don't require to import that. A method is a list of statements executed by invoking the method's name. Such invoking known as method call. Any method input values or arguments appear within the braces separated by commas if more than one appear. So a programmer must precede the method name with math dot to call a math class method. See, examples you can see over here: square root, power, and absolute are few examples of math dot methods. So like if you give square math dot square root of 49, then it will calculate the square root, which is nothing but the 7 value. Coming to integer division modulo. Division integer rounding. When operands are integers, the operator performs integer division which does not generate any fraction. Uh, like you see, in if suppose int w is equal to 10, wx is equal to 4. So y is equal to w by x, which is equal to 2.5. Coming to modular division, the basic arithmetic operators include not just plus, minus, multiplication or division, but also modulo. See, the modulo operator gives a remainder value. So in the previous thing like division, 10 by 4 gives 2.5, but in modulo operator 10 by 4 gives a value as 2, which is a remainder. And now you see 1 by 2 is 1. Reason 1 by 2 is 0 with the remainder of 1. So coming to type conversions, type conversion is a conversion of one data type to another, such as an integer to double is a type conversion. The compiler automatically performs several common conversions between int and double type. Such automatic conversions are known as implicit conversions. For an arithmetic operator like plus or in multiplication, if either operand is a double, the other is automatically converted to double and then a floating point operation is performed. So coming to typecasting, a typecast explicitly converts a value of one type to another type. So this is implicit conversion and this is explicit conversion. So you have to, this is the way how we write the explicit conversions, like average kids per family is equal to double of kids in family plus kids in family 2 divided by double of num families. Thank you.